morning. So testing mic 1 2 3. Can hear me? Just answer in the chat, or you can unmute your mic so that somebody can you just speak out so that I can confirm that I can hear you guys also.
Hello, can you hear me?
All right, I can hear you. Thank you. Okay, you can see the screen right now, my screen.
Yes, doctor.
Right. So I think I'm going to start now. So while we wait for the other student to come in. So I noticed that I think yesterday a few students messaged me, and then also in the Telegram group, and as mentioned, Telegram group is just to normally it's just a reminder. Everything instruction will be in Learn. So I think Jeffrey have mentioned that he didn't actually share to the other student, but anyway, if he did the feedback, no problem. It's just that for the other student, okay, if you go, let's just go to your Learn, okay. Let me see who actually did the feedback. Week 4, okay, reflection, yeah. So by the way, okay, every time we have class on Wednesday and Thursday, make sure that you go to Learn and follow the lessons. We have like yesterday we have lesson 1.4.1. 4 means it's week 4. Okay, week 4.1, lesson 4.1, 4.2, 4.3, 4.4. So normally, okay, if I have that description or during class, I mentioned that I'm going to give you a reflection, so go to Learn. So make sure that you do the feedback form, okay? And because, as mentioned, the attendance is there, the feedback form is there for the attendance, okay? Because normally, I think this is common now, okay? So then 8 a.m. class, what happens that you on the WebEx and then go and sleep, okay? Until 10 a.m., then come back again and then switch off, maybe, I'm not sure. But anyway, to confirm that student actually attended the class, then they need to answer the feedback form. And the feedback form, even though I say that it's a 5-point form, do not answer 5-point form, like each point form only one word, okay? And then it's actually copy and paste from the teaching plan, or copy paste from the learning outcome, the lesson learning outcome for that week. Okay, means that I know if you do that very short point form, means that you didn't attend my class, or you actually, sorry to say, but lazy, yeah? You don't put effort to actually write out the feedback form, and this is actually as a summary for your own self. Okay, so make sure when you do the summary, submit, then you copy, save it for your own reference. So as that one can be your own notes. So make sure that you do the reflection. Okay. So yesterday, apparently, look at the feedback form. Lo Yi-yin, are you speaking? Do you want to talk? Because it says that you are speaking. Okay.
Sorry.
All right. Okay. In the feedback form, okay, yesterday, I think the highest amount of response was on week 2, Wednesday. I have 56 respondents. But after that, it's actually declining, and I don't know what happened. Maybe a few of the students who joined week 2, they actually go change it to another section, or just drop the subject. Okay. So what happened to 56.7 and then become 48 students? So meaning that they didn't do the feedback form, and bear in mind, as I mentioned, feedback form is for attendance. So you see that attendance, we have week 1, 2, 3, consider week 3, feedback form is I refer to the assignment that you submit on week 3. That will be considered as the attendance. Okay. So week 4, okay, I already able it for you to actually upload in the, you can do the feedback form up until today at 10 a.m. Just that for those who didn't submit yesterday, who I open it for the sake of you guys who attended yesterday, for today, you need to update the feedback form 10.4. Means that a lot more. Okay, so that is the penalty if you didn't do the feedback form yesterday. So instead of 5, 10. So I will see that according to the feedback form, I can actually look at the example, show response. So I will look at the last to submit was yesterday, because the deadline was noon. So 11:59 last to submit was Low Yin. So we submit this one. Okay. So I just opened it for today. So for week 4, for Wednesday feedback, those who didn't submit, you can enter, but I would expect 10.4. So the explanation will be much more. Correct? So basically, okay, you have the point form there. Make sure that if it's too short, then make it longer, and don't simply just copy paste the contents. Okay, let me just go through the feedback. Okay, Aiman ada? Aiman? This one, Nur Aiman Hafiz, most probably didn't attend my class. This one, you can actually refer to the learning outcome for that week. Aiman? Are you there? Aiman? Tak ada. Okay, Aiman tak ada. But anyway, don't be like Aiman, like this. Means that I would say you didn't attend my class, just simply switch on, or you didn't even attend 8 to 10, because I gave you leeway time from up until 12 noon. So if you don't come to class, you can also fill in the feedback form, just that it will be very short. Okay, so I would know that you attended my class if you explain exactly what I have actually taught in class. So that's the idea of the feedback form. It's not lazy people writing up a feedback. Okay, no lazy people. If you are being lazy, then estimate the grade for this subject to get D. Okay. I'm being serious right now because I just repeat again. For signal system, last semester for BEKG program, okay, this semester we have BEKM, section 1 and 2. And as you can see, some of the BEKG students also attended. Some of those are direct entry students for each student, which is first time BEKG system. And some of the students are BEKG students who failed the subject last semester. And there are total 30 students. 30, 30 pelajar fail subject signal system. Okay? And I would like to remind, don't be that student to fail this subject signal system. Because if you fail what subject, what happens is that for the next semester, you're going to repeat it and you will add credit hours to your semester. Or even you need to do a special semester. Okay. So if you're taking the subject this semester first time, then please properly follow the lesson. Okay. Don't be lazy. Okay. As a student, if you are lazy, then don't be in the university. Okay. Just directly go and work. This university is not the place for students that are lazy student. Sorry to say that, but if you're lazy, then don't be a student. Because there are more students who wanted to join to enter the university, but you get the place, so please use that to the fullest to learn and get the degree. So you can do that. Okay, I will give you those who just enter. Okay, I'm opening the feedback form for yesterday. Okay, yesterday feedback form can be accessed. Show the switch rule because that's my switch rule. So you can go to week 4. Okay. Yesterday class I okay, this one lesson 4.4. Students should be able to look at this lesson 4.4 class reflection. So those who didn't do it, you can do it now. I give you roughly about 5 minutes to do that. For the other student, please open your slides, take a piece of paper. If you don't have a piece of paper in front of you, then just prepare for that. So 5 minutes, we will start 3 minutes. I give 3 minutes. We will start at 8:15. And after that, the feedback form will be closed. Okay, for yesterday feedback. So do it immediately. Right? 8:15. So I'm going to focus my mic. Right? Time's up. Okay. So it's already 8:15. We are delayed by 15 minutes. So we just let me. Okay. And by the way, I just yesterday I gave you an assignment, right? Okay. I asked you to submit a task yesterday. So those who actually join my class, you know that you need to submit something, right? So submit here, and the deadline was midnight yesterday. Midnight. So those who submit today means that must be something wrong. You didn't attend the class, and then there's barely today when I inform that it's that there's a submission. So one thing is that first we can go to the Tubular. So anyway, let's look at who submitted. Okay, participant I have 76, but this one is also from other student sections, section 2 and section the BEKC student, Dr. Ain. So some of them are in the class. So I will say participant. I do not look at participant, but I look at the submitted. Okay. So those submitted 49 is my student. Okay. So I will presume that just now the feedback form was 47. Okay. So yesterday 47 students actually answered it. So there should be only 2 students who do the feedback form today. Okay, because 49, kan? So, and basically, okay, in the submission, even though it's past deadline, I'll still open the submission. And you can see that those who submit after deadline will have the red indicator status. Okay, 7 hour late, submitted this morning. Okay, I do not know what's the problem. And then Hidayatul also this morning, 4 a.m. Tak tidur ke? Okay, tak tidur doing the task. So 4 a.m. this morning, just submitted. So I'm not sure what's the problem. Hidayatul, maybe Batman at night doing something. So at night, he only can do the submission. Okay, so so even though you think that you submitted, okay, past the deadline, but actually I can see that you submit past deadline. Okay, so do not repeat that again. Okay, so let's look at the feedback form. What happened? Any additional student actually joined, because this morning one student actually requested. Okay, only one additional. 48. All right. So okay, I think should be okay. No problem. So I'm going to close that feedback form. Because I didn't think the rest of the students who are not entered yet is not interested to actually join. So I'm going to close that yesterday. This was yesterday. Right? So remember for today, we have the same habit or routine. Make sure that, I'm not sure if for other courses, okay, using MS Team and so on, I do not like using MS Team because it's too not organized. So I would prefer using Lulen so that it's organized and you can actually follow the instruction. So week 4 for today is that, okay, because since yesterday, somebody actually messaged me and told me that, Doctor, I forgot to do the attendance. Okay. So how did you forget the attendance? Means that you didn't open ULEN? Okay. My suggestion is that during class, before starting class, go to the ULEN and look at what the heck did I need to do this morning before class. So first of all is that manual tick your attendance. Go to menu, the attendance, click on it. I'm not sure if I need to just demo it, but anyway, you are adult student. So for example, ASPA, okay, if you are present, then click on this, be present, then you are present lah. Okay, and that's all. It's like signing the attendance form only. Okay? It's not that difficult. And class instruction is now we are online WebEx and we have class activity as usual using Padlet. And towards the end, I'm not going to remind you today. Okay, class reflection, please make the feedback form by noon. But do not do it now because we haven't start class. If you do it now, then I know that you now means that now it's 8:20 kan. And somebody, the student, are going to do the feedback form by 9 a.m. Okay, we haven't finished class yet, so how can you do the feedback form? Okay? After class 10, then do the feedback form. Okay, this one pun nak kena bagi tahu instruction, because some student may be excited to fill in that feedback form. Right? So, okay, understood that? So, let's start. Okay, before we start, I never asked you guys. Actually, we are doing online class right now. Okay. Okay. You guys, some of you guys maybe in UTEC, especially for BEKC student. You are doing your FIP project, right? And then maybe third year student who are doing IDP. They are compulsory to come back to Melaka or UTEC. So can you just write there in the chat? I would like to know who actually back in UTEC. Write there in the chat. If you are UTEM, then write there UTEM. If no, then no lah. Okay. In the chat. I would like to know how many students actually. Yeah, I call UTEM. Okay. What else? reason why I asked, yesterday I was walking to the balapan. My routine. Okay, every day I have a routine. If it's not raining, I will go to the balapan or round 1 from FKE until the PPS there, KP there over there, right? And then return back. So the 1 to actually include my exercise, but just walking. So 10,000 steps every day. So I will do that after work, roughly about 5:30, okay, until 7. So yesterday I'm actually when I was walking towards the balapan, somebody actually, a student actually say hi doctor, and just hi. But I'm not familiar with that student, so maybe taking my subject, so I'm not sure. Okay? Only 3 students. Haikal, Shakirin, dengan Izzat. The rest? What about the rest? If you are in other country, Perak ke, KL ke, you can put there. Sabah ke, I would know who's from Sabah over here. Okay, I have one student, master student from Sabah, and he actually didn't go back to Sabah for 1 year. Okay, he was here before the COVID happened, and up until recently, on Monday, we just went back to Sabah. So roughly about 1 year since the COVID, because he needed to complete his master project. So 1 year he will go back. It's like doing the his master overseas. Didn't come back to hometown. Perak. Okay. Yeah, Perak. Oh, semua orang. Why you send me privately? You cannot send to everyone. Ija, Perak, Kia, KL.
I cannot send to everyone.
Pardon?
I cannot send to everyone.
Oh, okay, tak apa. If you cannot send to everyone, just send privately. It's okay. I'm just going to read it. Kia, Lia, Ali, Perak. Natasha, Selangor. Pun Perak. Oh, ramai Perak. Liu, Negeri Sembilan. Nawal, Johor. Oh, Aminuddin, Duran Tunggal. Tu orang Duran Tunggal. So, you ada jumpa saya lah kat Duran Tunggal. Saya duduk Duran Tunggal. Okay, Jeslina, Johor. Bong, Melaka. Okay, anyone else? Ni je yang reply. So, I will assume this is the only student who are actually listening to me right now. Huh? Rented house in Melaka. Trisha, Sarawak. Trisha, siapa Sarawak tadi? Jing, Sarawak. Nadir, Pintan. Pamen, Penang. Okay, alright. Okay, so all around, Next time they can invite Shakirin to go for a walk. Oh, Shakirin was walking. Oh, Shakirin is staying inside. Okay, sure, you can. I'm not sure who Shakirin.
What? I'm sorry?
Shakirin is a girl, kan? Shakirin.
Yes. I'm a girl.
Okay, alright. So, ini Haikal ada bagi tahu next time doktor can invite Shakirin to go for a walk.
What?
You're staying in Lestari? Go for a walk.
Yes, I'm at UTEM.
Okay. Alright, so I think so that's like opening lah for this morning class, kan? Okay, it's too serious. Start class pun boring juga, kan? So I'm interested for those from Negeri Sembilan. Actually, my parents are from Negeri Sembilan, but after that my parents moved to KL lah, because my father is actually a professor at UM. So we are living in Putrajaya Jaya and after that in Cheras. So, but before that, my parents were both from Negeri Sembilan. So they are from, do you know Kampung Tengkek? Yeah, there's a Jeram Tengkek over there. So it's from there lah. Okay, dulu saja near the Batu Kiki over there. Alright, so anyway, that's just ice breaking for this morning. Okay, so yesterday, remember what you did was I asked you, we did this yesterday? Okay, yes, we did prove this exercise yesterday. And then I asked you guys to upload as assignment, kan? As a task lah. It's not assignment. Assignment lain, later on there's already assignment that you need to submit. Okay, this one is so that when you submit this two example, this first signal and another signal, I can actually see if student really understood about the topic. So from what I have gone through some of your students' submission. So alhamdulillah, I think most of you guys understood about the topic. And then later on, maybe if you have time today, because they're going to finish chapter 1 today, and we don't have much slide to actually discuss later on. So maybe we can go through this example and look at the answer. And then, so let's go to continue with the topic. So we are going to go to the next topic on representation of continuous time signal. So as you remember, yesterday we have learned about both on continuous time signal and discrete time signal, and signal are represented as if it's continuous time signal, you know that it's represented by a bracket, normal bracket, and for discrete time it will be represented by a square bracket. Okay, so this is continuous time signal and this is for discrete time signal. I need to save first. All right. So if you see here, okay, example, we are going to actually look at how we are going to connect each of the signal. We are given one signal input xt. So interconnection of system consists of three elements. It can be a block, like what you have right now, a block. Okay, so you have a block, then you have an input, okay, which is xt over here, and then you have an output signal, which is represented by yt. Okay, so t here, for the case of this chapter 1 topic, we are going to represent t by a gain. Okay, t will be the gain. Okay, this one is not in the notes. I just add this yesterday. Okay? So this is not in the notes. So please make sure that maybe you can jot down that, or if you're using computer, just screenshot it. So this one will be represented as a gain. Gain means that a value. So it can be 1, it can be 2, it can be 3, and it can be 20, so on. So a value of gain. So when you present a block diagram, okay, I'm sure most of you, I think you mentioned the 2 BEKM student, okay, you mentioned that you are taking control this semester, control 1. So if in control 1, you are familiar with this type of block. And for those BEKG student also, for your student or those repeating, I'm sure you also taken the control 1 subject and you are also familiar with this type of block. So when you want to represent output yt, it will be represented as yt equivalent to, okay, refer back what is the gain value here. Okay, t times xt. Okay, so you will get the output signal, yt. Okay, this one is if you have a block diagram. Let's look at if you have a summing junction. Okay, summing junction. So the case of summing junction is that when you have two signal or more. So for this case is that you have, okay, you have signal x1, signal x2, signal x3, and then it's being summed at the summing junction here. So assuming that if it says here plus, so meaning that at this point everything is plus. Okay, so that's why when you write out the output, this is yt, you can write here yt, and yt will be presented as x1, which is the first input signal, plus t plus x3 t. Okay, this is very simple. And remember, actually you have been introduced to this summing junction in the chapter 1 topic before. Where did you learn about this summing junction? Anyone in the chat? Where have you seen this summing junction? In the chat? Right there? In which topic? Okay, Muhammad Rizwan. Good, very good. So you have actually saw this summing junction in the even and odd signal, proving the graph, right? So even and odd signal, you see we have the equation, and for the even we have plus, and for the odd we have minus. So it doesn't mean that for summing junction, okay, all will be positive. Okay, it can be that maybe at this point x3 is minus. Okay, so this is what it means. Summing junction is where we have a additional or subtractant. Okay, so if it's minus, then this will become minus over here. Right? And next one is the third one is product junction. So product junction is where you have two signal and it's being dot product here over here. So x1 times x2t, so you will get the yt value. Okay, so this one later on, but this topic we will be look at it in detail in chapter 2. Okay, chapter 2. Yeah. So next, let's look at the basic connection of the system. Okay, we have two types of connection. We have the series, or we call it a cascade, and we have a parallel. So for the series is that, okay, means that you have two blocks, which is a line, or which is put in series. So you have x, first input is xt, and then you have one gain, t1 gain, and the output from the first block is yt. Okay, so if you have something like this, normally you're going to do this, settle this block first. Okay, find out what is y1t. Okay, so that's why you have y1t equivalent to t1 times xt. So you get y1t, and then after that, only you move on to the next block. Okay, next block is this block. Okay, so in this block, the input is y1t. You have the gain here t2, and you have output y2. So yt can be written as t2 times y1t. Right? So very simple. Therefore, if you were to actually include all of this, okay, under one equation, you can write the equation as yt equivalent to t2 t1t. Okay, means that you have t2, right? What y1t is this one. Okay, just substitute t1t into here, and then you get the last. So you can actually summarize that t value is equivalent to t1 times t2. Okay, looks simple, right? Okay, and in contra is that you have a parallel block. So parallel block means that it is in parallel, up and down, like that. So you have the same input, in contra, same input, xt, and then you have the input is being inputted to the gain t1, t2, and the output of this t1 and t2 will be different output, which is y1t and y2t. Therefore, if you write this out, you're going to actually settle one by one first. And if you may, you can write out from the end here. Okay, so if you see here for this one, yt, okay, how you write it is that you start with yt over here. So yt, you know that is equivalent to the summing junction. Okay? y1t plus y2. Therefore, find out what is y1t. So y1t is this one, right? Okay. So you have this equation. Okay. And for y2 is this one. So you have this equation. And when you combine it, you will rearrange it, you will get t value is equivalent to t1 plus t2. Okay? Understood? Okay. So based on that idea, okay, so look at this example. Okay. What happened to last semester? lots of students actually fail this subject because they were not able to actually write out the equation for this block. Okay? In this equation, the student was given the signal y1t, y2t. Okay? So, sorry, not that. The student was given the signal xt. Okay? And the question was find what is yt. Of course, before you go to get yt here, there were a few additional question on time shifting, time transformation, okay, amplitude transformation, and then also even and odd. So before we go that, they were ABC, and then the final part D was to get the output of the system for YT given XT. So you see that if we gotten XT wrong in the beginning, time transformation is wrong, the procedure and amplitude transformation was wrong, then in the end it will actually add up to the marks. So this is really important on how to actually, because this one, if you can actually do it, it's very simple. Okay, so based on this, okay, let's do this example. So I give you based on this, okay, tadi. Can you write out? Okay, we do it one by one. Okay, we are going to, I'm going to ask you to write out what is YT, Y2T, okay, Y3T, right? Then Y4, and then YT. Okay, can you do that equation? And then from there, okay, assuming that, because if you see here, the value of the gate is given. In contrast to this, we have T1 as the value is given by T1. So let's say that this is T1. Okay, this is T2. This is T3. Okay, fine. So right now, find YT and then find also T value, which is what is the equation. Example, you can see that T value here was given by T1 plus T2. And for this case, for series, is that T is equal to T1 times T2. Okay, so I'm giving you 5 minutes to do that, right? And I'm going to open a Padlet so that student will upload that in the Padlet. Right? So I will give until 8:45. According to my time, 8:45. Yeah, Haikal ada message di chat Yeah, Haikal, the note is not the same because just now I mentioned, I just add it into the slide, okay? So, screenshot that, okay? As I mentioned, sometimes the notes, because I'm using the notes from last semester, normally I do not have time to actually pre-edit it earlier, okay? So, I will edit it before class. So, just take note lah, since we are using online right now, so boleh screenshot sajalah. Okay, don't be sad I think I saw somebody, what you did? Oh, lah, Yi Sui. Answer, what? Don't answer. I mean, upload your answer, right? I ask upload the answer. Upload your answer, like your name and matric ID. Okay, I saw that Un was typing the equation inside the text box, so I don't do that lah. Okay, you are doing a very hard time to type it in the Padlet. You have a piece of paper right now, just now, kan? Okay, write it on a piece of paper, your solution, then upload it. Okay, let's look at the answer because it's already 8:48. So Anonymous. Siapa anonymous ni Write your name in the text. When you type there, update. You can update, you click on this pencil. Okay, those just now whoever who upload this. Okay, edit. Click on her. You can edit your name. Okay, I can edit because I'm the owner of this palette, but you can update on your own lah. Okay. Right, and then make sure when you upload it in the correct position. I need to like sengitkan kepala. Look at this. Okay, so Chong, Sheng, right? Okay, I can eyeball if it's correct. Okay, Chang Li Jiashang, correct. Just now pun tak tahu yang anonymous ni siapa but your answer is also correct. Muhammad Zul Hakim, okay, correct. Un Yi Sui. Okay, your answer is okay, correct. Lo Yin, okay, correct. Aminuddin Haziq, what's your answer? Okay. No. What's your value for T, Aminuddin? Aminuddin, apa value T you? In the question is that find T, right? Okay. Pose Kiazi, okay, correct. Wong, correct. Li Jiajin, correct. Alright, so almost everybody get the correct answer. But I would prefer more. What happened to the Malay student and the Arab student? Are there any Arab student in this class? Or foreign student? Arab student and foreign student? Any of them in my class right now? If you are in my class, please write in the chat. I'm a foreign student. Write there in the chat. I am a foreign student, and where are you located? From which country? Iman ke? Okay. Pakistan ke? Korea ke? Last time we have a mobility student, inbound student from Korea. Okay, Aiman. Okay, Aiman. So Aiman Ahmed, did you upload your answer? I cannot see your answer. Tanzi, Arina. Arina comel dia punya icon setiap ada macam lashes. Alright, so I think basically most of you actually got the answer correct. So let's look at this one. Okay. So let's just do it together. If I'm wrong, then you can correct me. Okay? Because sometimes lecturer is also human. Salah tulis. Okay. So YT, we start with YT. Y1T equivalent to T1. Okay, XT. Okay. Then Y2T, yes. Who's there? Who's that? Lo Yiying? Dia nak bercakap ke?
Oh, tak. Sorry. Mistake.
Okay, mistake. Switch off kalau tak nak bercakap this is normal lah in my class kan. Kalau if there's somebody talking in the class, I will ask, do you want to share anything in class? Macam tu lah. Okay. So, well, if you want to say something, yes, you can say something. Okay. So, Y2T equivalent to, so Y2T is here, equivalent to T2XT. Right? And then Y3 is this one. Okay, we have done Y1, we have done Y2, so now is Y3. So Y3 is the summation junction just now. Right? So we have Y1T plus Y2T. So Y1 plus y2t. So if I were to actually substitute the value above, so you will get t1 plus t2 xt. Then next, we are going to do y. So y4 is t3 times y3, where y3 you have this value. Okay, so y3 substitute inside here, and you get t3 t1 plus t2, okay, xt. And therefore, you have the final value yt equivalent to, okay, yt is well, y4 kan, y4 plus, because it's a summing junction and because it says that plus over here in the middle, then both are plus symbol. So y4t plus, this is y2. So plus y2. So you have, where's y4? This one above plus y2. So we have y4. You're going to substitute here. Then you have y2. You're going to substitute here. So you will have y4 is t3 plus t1 plus t2 plus y2t. y2t is t2. So everything will be the value for t. Okay. So t value is t1 plus t2. 1 plus 2 times t3, 3 plus t2. So you have 3 plus 3 times 3, 9, 11. Alright, so you have the final answer, t is 11, and you have the yt value is this value. Okay, so you should be able to answer just now. Normally lecturer, when you mark the question, of course, the important is the procedure, the way how you do the calculation step by step, means that all of these are counted marks. All of this, all are marks. Okay, but for my case is that, or even other lecturer, normally we will look at the final answer. We know that if you get t equal to 11, then your master must be correct, your answer must be correct. And then after that, only we backtrack to all the steps that you did. Okay? If you did it correctly, then you get full mark. If you only answer t is equal to 11, or yt is equal to this one, so you may only get the marks for this one. But most of the time we will give marks. Okay, this is the way how we give marks. Because sometimes students they skip all the procedure, the method, the procedure, everything. They just write here the final answer. Yt is equal to this equation and t equal to 11. The thing is, this one is only considered 1 marks. 1 mark, 1 mark. So 2 marks only. So you give this answer, you get 2 marks. But the total mark for this question is that 10 marks. So you need to understand, it's like when you did your SPM previously. So you know that if it's a large mark, that means that you need to show the steps. Okay. So for that case, is that you have this here is 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, 1 mark, and so on. And it will be given cumulative is 10 marks. So this is sometimes why students think, oh, my answer is correct. Okay. You may get the correct answer because you copy from your friend the final answer. Okay, T11. Okay, you go to toilet for the face exam, you go to toilet and then meet with your friends. Okay, okay, this is answer. Okay, don't do that lah. Don't do that in the toilet, Okay, if you're caught, then you are going to be suspended for 1 semester. Okay, so this one is considered how you can get the full mark. If you show all the steps. So this was the answer, but anyway, we already did that. Okay, so I will next if we have time, we are going to discuss this one example. Already uploaded in Padlet, okay, about that, and also this tutorial session. Also, if we have time, we will go through, but I'm going to skip that. Okay, home. This is task that you can do at home. Okay, similar to what we have done on continuous time, you can also do this same question, okay, on time shifting and time scaling. Okay, so you have the discrete time signal, and you are given some properties here. So you have the time transformation, you have the amplitude transformation. Okay. Okay, this one also later I will discuss. This one is example. Okay, this one is example of midterm form exam for continuous time signal. Okay, so we see that this one is related to what you have uploaded yesterday. We have done the exercises to actually come up with the signal representative of this of the signal. Okay, so I'm sure you can do this question easily. And also for this one is for midterm format for the discrete time signal. Okay, for discrete time signal, if you see we are not given any signals. Okay, there's no signals, but you are given an equation. Okay, you're given equation GN. Okay, so from here is that you need to draw out the signal. How does it look like? So this is the main thing that you need to understand, how to draw the signal. But this is very simple because you see that the n value is at one point, and -3 and -2 until n3. So you just plot it accordingly. Then from there, okay, you're going to answer the signal transformation. So the idea is that, okay, student understood how to plot the discrete time. This one will have marks. Okay? And then after that, you are going to do the transformation over here, A, B, C. So total is 9 marks. So if you estimate, maybe this one is 2 marks, 2 marks, 2 marks, and this one 6, maybe 3. Example. Okay, means that we're giving you more marks here because if you cannot get the correct answer here, then this answer for sure is wrong. Okay, so an example. Okay, so I'm going to continue with the last topic, which is continuous time and discrete time system. So if you see here, physical system, anyway, I explained it in the beginning of the class on what are these signal and what are system. So, but example of physical system are signals, processing, communication system, electromechanical, motors, automotive, chemical plant. So if you are BEKC student, you have learned this in Introduction to Mechatronics. Introduction to Mechatronics system, right? So it's a system. And what you have learned in Introduction to Mechatronics are lots of systems. You have learned about DC system. You have learned, and you remember in the exam, final exam for Introduction to Mechatronics, you're given a case study of a system, and you need to choose the best selected sensors, the best signal processing method, or the best you need to have a controller, okay, and so on. So those are the things that what physical system is about. And all of this is, if you see in here, under the system, okay, a system overall, if you look, the definition is that viewed as a process in which input signal are transformed, which input signal are transformed by the system or cause the system to respond in some way, resulting in other signal or output. Means that you have a system. Okay? In contrast to just now on this block, okay, this block is represented as a gate. Values again 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. But for a system, the system is represented by an equation, a transfer function. Okay, this transfer function later on you will learn this in subject. Okay, how to derive transfer function for a mechanical system, or how to derive transfer function for electromechanical system. For the third year student, if you are third year already, pre-BKM, actually you are going to learn about one course, which is the subject, which is electromechanical system. So it's a focus on electromechanical system, means that electrical system plus mechanical system. So this topic is actually really related to the introduction to mechatronics, because you have learned all of the mechanism. What is our mechanism? Mechanism is mechanical actuator lah. Example, what you have learned before was ball bearing, okay, rack and pinion, gear, okay, what else? And other things, okay, a few things. So that are mechanical or mechanism. So when we talk about electromechanical system, it's the combination of electrical system, as you know it, you have the resistor and so on, or DC motor, that one is electrical system, plus mechanical. So when you have a DC motor, you cannot actually use only a DC motor without an Invariant. Normally you need to increase the force to the output. Okay, so you need a gear, additional gear for that. Or you need to have a chain. Okay? Or you need to have a rack and pinion and so on to actually convert from linear, from rotary rotation to linear rotation. So you need to have the mechanisms like that. So all of those things, when you combine electrical and mechanical, you need to derive it and come up with a transfer function. One transfer function that represents that physical system. So this will be the transfer function inside this system. Okay, and why do you actually need to have that transfer function? Any idea? Any idea? In a chat, what is the use of the transfer function? After you derive it, what is it used for? What is its useful for? Example, in final year project, okay? Normally, you can do in two methods, either hardware and software, but mostly for mechatronics students, they are going to do hardware. Okay? Hardware. So you have a hardware system. For my case, my student have a pneumatic system. So they have the pneumatic, they have the damping, they have the spring value, and so on. Okay, so based on that, they need to derive the transfer function of that system. Reason why that transfer function will be used for simulation. Okay, so when simulation of what? Simulation when you want to design a controller. Okay, so a controller is something that either way you have a setup. Okay, you give a signal to the input to the hardware, then you get an output. So this is what it means. Okay, so it means that when you have a system, okay, input signal will actually cause the output. Okay, output signal. So input here, whatever input signal that you give will actually give an output. Output normally will be what you have learned in Introduction to Mechatronics. Output will be motion, will be in terms of force, okay, and so on. But because we are talking about in signal system, so we talk about input is a signal and output is also a signal. Okay? And this continuous time signal can be represented as discrete time, and normally why it need to be represented as discrete time is because when we convert or we want to apply a controller using a TSP board or even Arduino, you're familiar with Arduino, right? Arduino is actually a smaller version of the PSP board. Okay, so Arduino is very simple. You give an input signal, okay, you give a voltage, okay, and then you get a movement of the DC motor and so on, or light will on and so on. So it actually indicates a continuous time signal, but when it goes into Arduino, you need to actually sample it. So that is why we talk about sampling in the beginning of chapter 1. Okay, you sample the T is sampled by 0.1 millisecond example. So this is where you get the discrete time. Okay, the more smaller the sampling time, the better, because you can sample each of the value in the signal. If you have a larger sampling time, means that some of the data will be lost. Okay, so this one is basically what I explained. So you have the continuous time signal. So what happens is that if you want to use the PSP board or Arduino, we need to convert it into discrete time first. So that's why you have learned in Introduction to Mechatronics, A to D converter, okay, analog to digital converter. And then you do whatever process that you need here. You want to design a controller, you can do that. You need to send it to a sensor, you can do that. Okay, and then after that, since you want to send back the signal to some monitoring system, okay, or you want to send it to a lab, okay, to switch on the lab. So you will want to convert it back to the continuous time signal. So you will have here the A to D, analog to discrete time, and then after doing all the processes, you are going to convert back to from digital to analog. Okay? And most of the time, for each of the processes here, for the continuous time signal, okay, later on, you will learn that right now in signal system, you learn about the time domain. But in control, normally they won't do the processes of the transfer function in the time domain. They are going to actually use the Laplace transform, which is in S domain. Okay, so the continuous time will be evaluated in using Laplace transform. And then when you convert it to the discrete time, then you are going to use the Z transform. So Z transform is one of the topic under signal system, which is in chapter 5, the last chapter. Okay? And then after that, you are going to convert back to the Laplace transform. Okay? So later on, we are going to learn part of it, but only on the Z transform. Laplace transform here will be used. I think it will also cover in engineering maths also, not Laplace transform. Okay, which is as the S domain. Right. So an example of a system. Okay, I give you an example, which is motor driver and feedback control. Okay, I have mentioned that we have example. This is electromechanical system. Electromechanical system, right? So we have electrical system. We have the rotor, they have the stator over there, and then also you have the gearing function over there. Okay, so you have the motor, which is, we call it as the DC motor. And let's say that in control, whatever combination of electrical plus mechanical, we call it as a system. It's a system. Okay, you want to control something, so you want to control a system. So the system need to have an input. Okay, just now the definition, and the system need to have an output. Okay, output is something that you want to measure, and most of the time, you want to monitor the movement, okay, or the force, or you want to see it if you're connected to a lamp, and you want to see that lamp lights up. And because system normally is a feedback form, feedback system, so you want to have a sensor that can actually give feedback to the input again. So that's why you learn in Introduction to Mechatronics was you learn about the sensors, you learn about the signal processing. Okay, so in under the DC motor here, okay, DC motor, as you know, the shaft is going to move, the rotate, and that motor will be connected to something. You want to connect with the tire and so on. Okay? And then because you want to look at the rotation. If you do not have a sensor, you can only see that the motor is going to rotate. DC motor, normally you don't have a sensor. It's only given output, rotate. That's why if you are doing designing a mobile robot, normally students do not cater to an encoder. Okay, or encoder is a sensor. Right? So you guys can send an input. Okay, you give it a voltage and then it's moved. And then you want to stop it, you stop the signal, and that's all. Okay. So if there is overshoot and something, you cannot actually cater to the error there. Okay. So to actually cater to the error, you need to have a feedback, and to have that feedback is that you need to have a sensor. So for this alone, we have the encoder. So encoder need to be connected to the DC motor. Okay. So most of the time, I think if you are familiar with Arduino, you can actually buy a DC motor that has already a bit expensive than the normal DC motor. Okay, and that encoder will actually give feedback to the microcontroller. So normally reference here is the reference to the input. Okay, and you have the signal to the motor to rotate. What value voltage do you want? Okay, so this one is how you actually drive a system. The or you want to control the speed of motor and so on. And this one is a more detail. If I go to detail part of the motor here, okay. So motor is consists of this one. So you have the top value, the driver for the motor. You have the tachometer, the encoder to actually monitor speed. Okay, and then you have also the position to which is to monitor the encoder to monitor the position. And this is all going to be going back feedback to the microcontroller. So this microcontroller is something, example is Arduino just now, or Raspberry Pi, or you have the other DSP board. Okay, in my case, for my student doing master or PhD, they are using microbox. It's more powerful. So you can actually, we can run the analysis using sampling time of 0.1 millisecond. Okay, compared to Arduino, I think 1 second saja. Okay, this is so that's why if we have we are going to do more research. We doing FYP, but FYP are doing using microbox. So this one input is something that you want to control the DC motor. You want to control the DC motor move angle of 90 degree. For example, this is 0 degree, 90 degree. Okay, you want to control the movement. So you set a reference over here. Okay, and it will go to the output. Maybe there's an error. It only goes up to 85 degree. So based on that error, it's going to be feedback and where you will have a controller to adjust it so that it reach to 90 degree. So this is how it looks like. And if we go to detail, okay, load here over here means that end of the DC motor, you connect it to a tire, you connect it to something that you want to move position. Okay, you have a steering wheel. Okay, you connect to the end of the motor. If you have the electrical power steering wheel, so you have a motor that actually control the load, the steering wheel. And this will be more detailed, as I mentioned. Okay, the system over here, the system is comprised of a transfer function. So this will be how the transfer function look like. Representation of the transfer function of the DC motor. Okay, for those BEKM students, free BEKM, later on when you are third year, you are going to take the subject which is on electromechanical system. So you are going to learn how to actually derive the system and get the transfer function of the GS. So GS is actually the transfer function of the motor. Okay, but this is just an overview. So you have a DC motor, then desired speed and so on. So I think just an idea lah, okay, how you're going to do that. And based on that transfer function, this is only for the transfer function of the motor. And you see here, this transfer function of motor is only this part. Okay, remember what was the idea of a control system or a system is to control something, control a position. So when we talk about control, you need to have a feedback. So that's why you see that there's a feedback to the reference here. Okay, so this feedback will actually you will learn in the control subject. Okay, I'm just going to skip that. This one is an example of what I have in my laboratory. My student, my master student actually designed this. Okay, we designed it from scratch and we developed it, fabricated it. So the student actually developed this rotary SRA, and then this rotary SRA, what drives it is actually the current input. So we have current amplifier, we have 3 current amplifier, will actually control the SRA, this system. Rotary SRA, I call it as a system. And then rotary SRA here, we are going to connect it to a rotary encoder. So if you see here, this one is the encoder at the end here. It's connected to the shaft, the moving shaft. So that moving shaft will be the input which is going to control the rotation. Okay, so digital, this one will be the DSP port lah, and we are going to use the host PC, which is MATLAB, to actually control it. Okay, and additional part for the current amplifier here is we can actually monitor the current. Normally current amplifier we just give the current out, but are you sure that the current out is 1 amp? Okay, So we have the current monitor to monitor it, means that we can actually download, get the data, save the data, and plot the data, and look at what are the effect of input to the output to the position. So this current amplifier costs 1 cost 10K or M10K. So it's using brand name. Yeah. So example, if you see here, you see this, it's moving back, right? So the top video is on the PID controller, what we developed is the modified PID controller, which is the improvement. So let's look again. What's the difference just now? Look at the vibration. You see that this modified PID controller, it actually stopped directly. It doesn't like stop like that. Okay, no vibration. So the error. So yeah, direct stop. I'm going to show the PID. See here. It's going to stop. So it is represented in this graph. So you see that this graph, this PID is the blue line. So you can see that the PID is actually vibrating. Okay, displacement is oscillating until it goes to steady state. Okay, in contrast to the modified PID, you can see here that this red line is that it only goes up and then it's steady state directly. So you see. So that is what is the development of the controller to improve. We call it in our lab, we are doing research on precision engineering, means that on precision control, it means that it's very small displacement, and the displacement is actually in micrometer. Okay, displacement. And this one is another experiment setup that is been done by my student. So this one is a tubular type actuator. Okay, same concept, is electromagnetic type actuator, and we have the encoder connected to the end here. Okay, it's going to send read the positioning linear, and we connect it also to the load cell at the end here. So we are using 3 different amplifiers to actually move the actuator. Okay, and also here you can see the DSP board. We have the linear signal processing. We have the convert back from the analog to digital. And also we have the counter, because for the encoder we read according to counter. So if you remember in sensor chapter, how does the encoder, the procedure of the encoder? Okay, let's look at this video. Okay. So what happens that when you give input, you have this one is on open loop. We are right now we already done on a closed loop, and this one is how it looks like. But this one is one side. Just okay. Before I go to this part, can we take a break? We take 10-minute breaks. We come back again at 9:30. Okay, 9:30. Okay.
Okay, doctor.
Okay. All right. It's 9:30. So we're going to continue. Everybody in? Everybody in?
Doctor.
Okay. 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 All right.
Doctor.
Okay. Thank you. So we're going to continue on this continuous time and discrete system. So we are going to use an example of electrical system for this case. Okay. So RC circuit. So find the input and output equation related to the input signal and output signal. So just now you understood that for a system we have a block diagram. We have the input and output. Okay. For the case of this, we have input xt, output yt. Right. So looking at this equation RC circuit, you have the input which is Vs, input signal Vs, and then you have the output signal Vc. Okay, Vc is something that you're going to monitor lah, the voltage across the capacitance. Okay? So input, output. So based on this, okay, you are going to find out the relationship, the input output relationship. So even though I've given you the answer, but let's do this, derive it. Okay. Okay, first of all, what you need to do is that, okay, start off with the, you know that you have I here, the current value. Okay, so you start with I across current across the resistance. We have IR equivalent to Vs over here minus Vc. Correct? So you have the voltage, kan? IR, so you have Vs minus Vc. Okay, and then this equation you can actually come up with the equation I lah. Okay, so we are going to write it Vs minus Vc over I. So this one will be the first equation. Okay. Okay. Oh, what happened? What happened? Okay. Where's the PowerPoint? Okay. So next is that you know that we have the voltage Vc output. So let's try to derive for the I across the capacitor. So you have I equivalent to, this one is the equation that normally you know this equation actually in physics you have that list. Okay, just okay. So you have I equivalent to C, the capacitance here, which is dVc over dt. Okay, so you can write this as the second equation. Okay. So let's say that you know that equation 1 and 2 is actually the same I. Yeah? So let's write it as I1 equal to 2. So you are going to write Vs over R minus Vc over R equivalent to C dVc over dt. You have learned about circuit theory, so should be you have no problem with this. Okay. And from here is that we are going to look back at what was the question. Okay. The question was find the input-output relationship. It means that you need to come up with the equation which has the Vs and Vc term inside that equation. Okay. So looking back to that equation, we are going to try to leave the dVc at the end there, right? So let's say this one be your Vs. See here, keep it down. Okay. So from that equation, you're going to write S over CR minus Vc over CR equal to dVc over dt. Okay. Just now I'm going to write out the equation of this equation. Okay. Let's say that we are going to write out the equation. Xt input is the Vs. Okay. Then you have Yt we have output is DC. Okay? And you notice that you have this dVc over dt. So basically you have y over dt, right? So which is equal to dVc over dt. So you are almost there lah. Okay. So if you were to rewrite this equation, you can actually rewrite this. Okay. So we have dVc over dt or then plus rewrite this, take out the VC value under this one. Okay. So we have dVc over CR equivalent to Bs over CR. And due to the fact that you want to relate it to the input output, so we are going to change it in this term. Okay. So you have in the end you have the y over dt plus what is VC? VC is yt, and you have 1 over CR. Okay, equivalent to Bs, which is your xt. Then you have the 1 over CR. Okay, if you were to rewrite this, you can actually rewrite it, and then you will get A equivalent to, if A is equivalent to CR, then you have y over dt plus yt, ayt equivalent to axt. So you actually written out the input-output relationship between the input-output. Okay. So that's why you see here, okay, this equation is represented by this equation. Okay, but assuming that because in the case of this part, A is the same, so I'm using A and A, right? Okay, understood that. So this one is one more example of you have of a feedback, but this one it's not the same as what you have seen in the cascade block. Cascade block, you have the summation point over here. This one, if you see here, is that it's an input here, or normally we call it as the reference for a closed loop. Then you have system 1, system 2. So, and there's an output over here. And there, the output of system 1 is going to be feedback to the system 2. And this one is normally is the feedback. Okay. So, if you were to represent this, you can actually represent it in terms of a simple capacitor, or you can write it as this equation. Okay. Input, current, and output here, and you have the capacitor resistor in parallel. So we are going to go to the last part, which is on basic property. So very fast on this. This one is on basically on the theory. What are systems with and without memory? What are causality? What are stability? Time memory system and linearity. So for system with and without memory is for memoryless system. It means that no memory. System without memory is that it says the definition is that it depends only on the input at that same time. Meaning that if you see this equation, here you have yt, yn equal to 2xn minus xn squared, the whole thing. And you see here that it's all at the current value xn. There's no time shifting. There's no x n minus 1. There's no x n plus 1. Okay, this is advanced. So it doesn't actually depend on any of the past input or the present input. Okay, it's only at the input at that time. Okay, so this is what you mean a system without memory. Okay, it's not going to be collecting any data. So normally this type of system is a system that has no sensors. Okay, because it's not going to collect data. You only give out the data, then hope that's all. You will see what's the output, and you will see the output. If you have an oscilloscope, then it will be shown on the oscilloscope. That is what it means. Okay, and for system with memory is that it depends on the previous input. So this is something that you a very good example is a closed loop system. Okay, a closed loop system is a system that is depending on the previous input, previous error data. then based on that, you are going to actually improve the system. Okay. So how do you know that it's actually a system with memory? You know that there is a time delay. Time delay is time shifted, and so it depends on the time that is being delayed in previous time axis. And for causality is that causal system is when the output is depending on the input at present times and in the past. So present time and in the past. So if you see here, present time means that it depends on xn. And then in the past means that you have the xn minus 1. Okay, so this is what it means. So if you look at an equation, for example, okay, given this signal, determine if the signal is causal or non-causal. Okay, so you need to understand that, oh, okay, you need to look at the signal. Okay, if there is a time delay, then we need to determine if it's a causal system or non-causal. Okay? And for non-causal system is that depends on future input. So it depends on the present time also, xn, and future input. So normally this is where you are going to use very advanced controller, for example, neural network. Neural network is intelligent AI, artificial intelligence controller. So neural network is depending on the future input. So it already can estimate what will be the future input. For example, Tesla car, it can estimate that if you see that there's somebody walking, so they can estimate that if that distance, then the car need to brake. So this is what it means, depending on the future input, non-causal. And next we go to the stability. So stability, normally when we talk about stability, this one later on we will discuss in chapter 5. But most of the time when we talk about stability in a controller, is that it's being bounded, okay, by some value. Okay, and if it's, you know that it's stable when, for example, just now I show you the graph that it have a reference input, then it's going to go to the reference and then it oscillate and then steady state. So if it's steady state, okay, then means that the system is stable. Okay, but if it's going to oscillate non-stop, okay, then the system is not stable. So in controller, you will learn that if you have the Laplace transform later on when you plot the rules and RHs, you know that if you plot the pole, okay, pole on the left side, then it's a stable system. If it's plotted on the right side, then it's a non-stable system. And next is time invariant system. The time invariant system is a system called if a time shift or delay. Time shift means that if it's a delay or advance in the input signal will causes the same time shift in the output signal. Okay, meaning that, okay, and this one we will discuss is next in chapter 2. Okay, so continuous time signal, if it means that if you have a shifting in the input t minus tau is a value, okay, then you also have a shifting in the output. So that is what it means. Okay, and also vice versa. If for the discrete time, if you have a shifting in the input n minus k, then you have a shifting in the output. Okay, I'm not going to go in detail on this because in chapter 2 you have the whole chapter to discuss about time invariant system. And next is linearity. Okay, so in general we have the additive property. So additive property, if you see here, is that if you were to have this signal, AX1N, okay, plus BX2N. So if you add input X1 and X2, then you will get the same output, AYN plus BY2N. Okay, or for scaling property, you will have this value. Okay, and these two knowns are known as the superposition property. So let's look at one example. Okay, to give an idea how to actually determine that the system is linear. Okay, so given a system with the input output related yt equal to txt. Okay, so if you're asked to check if the system is linear, so let's consider two input based on the original signal yt equal to txt. Okay, this is original signal. We are going to assume that there is two input x1t and x2t. So I'm going to write out x1t, okay? It's actually related to the input just now. Will relate to the output yt, refer back to the origin signal, y1t equal to t x1t. So you get the first equation, okay? And then we have the second input, x2t. You can write y2t as t x2t. So second equation. So how do you confirm that it's actually a linear? Okay, to confirm that it's a linear, we are using the additive property. This one, okay. So we are going to use that, okay, express xt as x1 plus x2. So you can rewrite again xt. So let's say that you will have xt here, x3t is equivalent to x1t plus x2t. Okay, and x2t, since x3, you are going to assume that it has a value, okay, a and b x2. Okay, so based on that, use the same way. So x3t, you will have xt3. Then you can write y3t equal to tx3. Right now, what you need to do is that substitute the value that you have done. Substitute value is 1, x3. Where's x3? Just now this one. So you have t a1 a x1 plus b x2. Then you get a t x1 plus b t x2. If you actually reorganize it, you will get a equivalent to, remember just now, you actually write out y1 and y2. Okay, this is actually y1. This is actually y2. So if you get this one, you will see that y3t is representing to the linear system just now. Okay, linearity property. So it's linear. You have ax1 plus bx2, you will get the output. The linearity is the same. Okay. So I think you can just go through the example if you have time. Okay, for this one is another example of non-linear system. You just go through this example. You are given the origin signal. Check if the system is linear. So using the same example, x1 and x2, substitute it, and then in the end, you will get y3t equivalent to this equation. Then this equation does not reflect to the linearity. Linearity is that this equation of additive property. So it means that when you see that, when you derive it and then it doesn't actually represent the additive property, then it's non-linear system. Okay, so very easy. Linear system, if I were to ask student, okay, is your system linear? Linear system is that when you give an input, okay, for example 0 to 10, you get also the same value in linear. Okay, so you know that it's a linear system. For non-linear is, you know that if you give an input, okay, 0 to 10 value, a step input, okay, your output will give a exponential. This is a system that is non-linear. Okay, so this is directly you can see that this is non-linear system. Okay, but you need to prove it. Okay, this one is an example. Okay, we have time now. Okay, I do this example. Okay, so consider the system yn equivalent to 2xn plus 3. Okay, check if the system is stable. So let's say that I'm going to assume that given x1n equal to x2 equal to 3. Okay, in the exam, normally this value will be given so that it's easier. Okay, or you can actually give your own value. Okay, so it depends in the question. If the lecturer asks, okay, choose your own value or choose the value according to your metric ID, the last 2 number of your metric ID, then you use that 2 number of your metric ID. then we're going to prove the system. So again, we are going to prove it using x1 and x2 just now. So x1n, we can write it yn, okay, equivalent to 2x1n, okay, plus 3. So what's the value? 2x1n. x1n is 2, we already substitute the value. So x1n 2 is 3, 2n 3. So we have 2 times 2, 4, 7. Okay. And next we are going to derive x2n. So y2n equivalent to 2x2n plus 3. x2n is 3. 3 times 2, 6. 6 and 3, 9. Okay. Now we are going to prove. So proof using x3. x3n. Okay. So where x3n, we are going to use x, which is x1n plus x2n. Okay. So let's see that we are going to write out x3 and write it out y3 and 2. What is xn? So x3 n plus 3. Okay. And then you already calculate just now that x1n is 7, x2n is 9. So substitute that. If I go to substitute, I'm going to substitute here. Very easy. So 7 times plus 9 is 16. So 16 times 2. What is the result that you get? Somebody calculate. Oh, sorry. Not, that is wrong. Nobody actually. Everybody is only following what I'm writing. What do you get here? X3. Somebody write that in the chat, or you can just unmute your mic. What is x3 value? What is x3 value? 5. Okay, 2 plus 3, 5, Okay, good. Okay, so you are there. Right? So right now we have 2x3. So just substitute that 2 times 5 plus 3. So we have 30. Okay. So this is first proof. Now you're going to prove that is it true? Okay. So you know that you have y3 output equivalent to y1 plus y2. Okay. Having said that additive property just now. Okay. So we are going to add that up. So y1, what was the value? 7, right? This one y1. This one was y1. Right? So 7 plus 9. What do you get? 16. Okay. So is it the same? This y3 and this y3? It's not the same, So meaning that after you prove this, means that this is not a linear system. This is how you prove that this is not a linear system, okay? You have the end result here is 13, you have the end result is 16, okay? So that will be the way how to prove it if you are given an equation, okay? Okay, I think I am at the end of the topic right now. We don't have time. So I would suggest, okay, I already upload I'm going to open, okay, I'm going to ask either you want to upload this example as a task. Very simple, because if you do this, then you will score for the subject or your midterm. Okay. So I have a few tasks, a midterm exam, and also this session and also homework. Okay. So there are 4 content. This one tutorial session, this one, and also this one. Okay, and I already link it to the Padlet. Okay, Padlet, we have the here, and also the tutorial, which is actually I say here that do this for A grade for the subject, so it's option lah. But I would say that the one that you need to do is that this example. Okay, I'm not going to open any submission in Moodle. Okay. Just that please do it later next week if you have time. We are going to go through this example or before the written exam. Okay. This example, compulsory to do it, and also this one. Okay, so there are two questions. This, if you are using your handphone, then screenshot it very fast. Okay, this, and also this one. Okay, so we are at the end of our lesson for chapter 1. Any question